Greetings, my name is Khalid Mohamed. Today, my group mates and I are going to be presenting about our design of reinforced concrete structures project. First and foremost, I'd like to thank Dr. Osama Abed for his supervision and instructions, as well as showing us the importance of project-based learning. In this presentation, I'm going to briefly introduce the project, talk about the problem we have in our hand, list the objectives, talk about design of different slab systems as mentioned, design of beams, design of columns, last but not least the foundations, and finally conclude everything up. Our project is designing a 5-story office building that consists of different structural components such as slab systems and continuous beams, columns, and foundations. The problem is that we have to design the different slab systems that are to be designed in a 2-way slab pattern, which are, that I mentioned earlier, the flat plate, flat slab, and solid slab. We used several design software to fully design every structural component such as DAD, SAFE, and AutoCAD. The objectives of this project is to design different slab systems, as I mentioned previously, design continuous beams, design the columns, whether it's sway or non-sway, design the foundations, and finally provide full detailing of each and every structural component. Before finding the initial slab thickness, we need to find the initial beam and column dimensions. From this table shown here, by using these two equations, we can find the initial beam height, which we found as 750 millimeters. We assume the beam width is 300 millimeters, therefore we can continue the design. The initial column dimensions can be found by the dead load, multiplied the slab thickness by the garment concrete, plus superimposed dead load. The live load was given. The ultimate load as shown is the sum of both loads. The largest area and the largest load are found, and the values are shown here. By using the formula shown, we can find the column dimensions, which are 550 by 550 meters, assuming that the column is a square section. The flat plate system. This table here shows that the slab thickness can be found by dividing the clear span, which is the largest span in the slab, which is 8.3, minus the column dimensions mentioned earlier, dividing that by 33. We find the slab thickness as shown equals to 250 millimeters. Next, we need to check the slab thickness against deflection. Using finding the moment of inertia for the slab and the beam by these dimensions shown in the figure, we can use this graph to find the alpha F variable, which we found as 7.5, meaning that the beam at the edge of the slab is considered an edge beam. Hence, the equation we used previously is correct, and the slab thickness is safe against deflection. After that, we move to the design of punching shear. The ultimate shear was found to be 1,100 kilonewtons. The shear of the concrete is 1,136 kilonewtons. It's bigger than the ultimate shear, hence that the slab thickness is safe against punching shear. We move to the design phase. Now we have the column strip and middle strips of the slab. This figure here shows the column and middle strips in the long direction. This figure shows the column strip and middle strip in the short direction. After that, we need to find the static moment using the formula shown in the slide. In the long direction, the moment was found to be 850 kilonewton meters. Short direction, 715 kilonewton meters. This table basically shows how to calculate the moments in each and every strip. For the sake of this presentation, I'm going to briefly talk about the design process. We carried an Excel sheet that does the design process from A to Z. All we have to do is put in the moment value and the strip width, and it gives us the reinforcement ratio, and the reinforcement area, and the bars. This is the Excel sheet for the middle strips. As you can see, it shows the number of bars and the specifications, as well as the area of steel per meter. Finally, we need to find the area of steel by using this table. We can select the area of steel by knowing the area of steel in the Excel sheet, and that's it. Thank you for listening.